discuss using linear algebra to solve the Cambridge diet. In this video, we're going to take a quick gander at computer graphics by solving this problem right here. So I've already taken the liberty of drawing a triangle. This is the shape we're going to be manipulating, and we're going to be doing three things to this triangle. We're going to be scaling it, rotating it 90 degrees counterclockwise, and translating it up 3 units and 2 to the right. So the first thing we're going to do is, you might be thinking, hey Sal, how are we going to use linear algebra to perform these operations? And I'll show you. We're going to start by representing our triangle as a matrix. And so this is quite a simple operation. We're just going to create a matrix and put the vertices, again, the vertices of our triangle right here, into the matrix. So our first matrix has the coordinates 2, 1, then the second matrix has the second vertice has a coordinate of 5, 2, and then finally we have 3, 4. And so this matrix, again, represents our triangle S4 shape. So next we're going to have to work on scaling this by 2. So how can we scale this matrix by 2? We're going to start by creating our identity matrix. So this is going to be a 3 by 3 identity matrix. And so next we're going to dilate this identity matrix by 2. So we're just going to multiply the entire thing by 2, and we're going to get this new resulting matrix where each of the pivots are 2 instead. And so when we multiply this matrix by S, and we'll represent this matrix as K in a second, we multiply these two matrices together, this will scale S by 2. And we can perform the operation, but let's quickly move on. We don't have much time. So next we're going to try and rotate this 90 degrees counterclockwise. And so again, we could start with our identity matrix, but we're just going to skip some steps here. And we know that in previous lessons, we can rotate something using this general structure. It's going to be cosine of theta, negative sine of theta, and cosine of theta. So in this case, theta is going to be equal to 90 degrees. So let me fill this in for you. And again, this needs to be 3 by 3. So we're just going to add a 1 in the last pivot. I think I need to start working on my finger strength because moving this mouse is not easy. Okay, great. So if we multiply this matrix, and I'm going to designate this as H. If we multiply matrix H by S, we will, again, rotate this 90 degrees counterclockwise. Finally, we're going to work on translating this matrix up 3 and to the right to 2. So we're going to create one final matrix. Again, we're going to kind of start with our identity matrix here. But instead of this, we need to next translate our thing up 3. So for the y coordinate, we're actually going to write a 3 here. And we've learned about why we would do this in previous lessons, so I'm going to skip over that. And we're also going to move it to the right too. So this is going to be positive. And so when we multiply this matrix, and again, I'll call this matrix A. When we multiply this matrix by S, it's going to translate it up 3 and move it to the right too. So it looks something like this. And to the right too. To the right too. And so our triangle would look something like this, if you can kind of see that there. We've created these three matrices. We're now going to multiply them together. So first we're going to scale by 2. So we're going to scale by 2. So we're going to put K here. Then we're going to rotate 90 degrees counterclockwise. So we're going to multiply to the left. So we're going to do this. We're going to write H here. And then finally we're going to translate up 3 and 2 to the right. So we're going to do this. So this is AHK. And so I'm going to finish this matrix. So again, this is a composite matrix. Composite matrix. And go ahead and multiply these three matrices together at home. I'm going to be doing this on my handy dandy calculator. You can do this on a sheet of paper if you'd like a challenge, or you can use a TI-84. But regardless, go ahead and follow along at home, and I'll get back to you when I'm done. The composite matrix. And so the last thing I'm going to do is I'm going to multiply this composite matrix, I'll just call this J, by S. So we're going to do Sj. So Sj. And this is going to equal, and again, I'm going to whip out my calculator real quick and do this problem. You can go ahead and follow along at home if you like. And I just completed the final matrix. So this is the end matrix, is if you perform all of these operations. And I guess one thing to note is this is the boundary of Khan Academy. We don't usually talk about this boundary, but it's always there if you ever watch my future videos. Anyways, this is a brief introduction to computer graphics using linear algebra. I hope you enjoy it.